When we built our nucleus in class, we actually had quite a small nucleus. So the number of protons and the number of neutrons were quite low. However, what we did do in class was make it an unstable atom. We did this by increasing the number of neutrons. So we originally had one on this line, and then we increased it so it was going over further on this side. But atoms don't want to be unstable. They want to be at a ratio where they're able to stay together quite comfortably. They want to be at these black points. So they'll actually radioactively decay to become these stable points and become a stable atom. Now, when we're talking about radioactive decay, we're talking about particle decay. What they are our three types of radiation that are appearing on this graph. On the graph here, we have our alpha decay, our beta plus decay, and our beta minus decay. All of these help an atom that is unstable become stable by reducing its number of protons and neutrons, decreasing the number of protons, or decreasing the number of neutrons. In addition to this, we also have a different form of radiation, what I'm going to call energy radiation. This sort of radiation is our gamma, our X-rays, and our ultraviolet rays, which are all electromagnetic waves. The reason why we care about radiation is because it can ionize. Alpha and beta both ionize quite strongly. However, because alpha ionizes so strongly, it doesn't penetrate very far. Beta ionizes slightly less than alpha. It's still able to take the electrons from the atoms that it comes across. However, because it's a smaller one, it can travel deeper into a substance and is more penetrating. Our energy radiation, though, has massive amounts of penetration. So gamma, X-rays, they both need lining in lead. While ultraviolet is still pretty bad, but you can protect yourself from it with a shirt and some sunscreen. If you don't do that, you can still get burnt and you can still get cancer from the ionization effect from it. So that means that even though alpha is super strong compared to the ionization of gamma, because it is so strong and it is such a big particle, it can't penetrate as far as gamma. So we need to provide more protection for our gamma than we do for our alpha.